Ever wondered how complex processes are simplified? Welcome to the fascinating world of flowcharts. These ingenious diagrams are the unsung heroes behind the scenes, bringing clarity to the complex and order to the chaotic. Imagine you're looking at a beautifully choreographed dance, where each movement flows seamlessly into the next. Now imagine if you had to teach that dance to someone else. You'd probably break it down into individual steps, right? That's essentially what a flowchart does. It takes a process or an algorithm, which can often be as intricate as a dance, and breaks it down into manageable, understandable steps. These steps are then represented visually, making it easier to grasp the overall flow of the process. This is especially useful in fields like computer programming, where algorithms can be quite convoluted. With a flowchart, a programmer can see at a glance how the algorithm works, what the input is, what the output should be, and how the program gets from one to the other. But flowcharts aren't just for programmers. They're used in a wide range of fields, wherever there's a need to understand a process, from business process modeling and system design to education. The beauty of flowcharts lies in their simplicity. They use standardized symbols and shapes to represent different parts of the process. For instance, there's a specific symbol for the start or end of a process, another for a task or operation, and yet another for a decision point where the process could go in different directions. Each symbol has a specific meaning, and when you string them together, you get a clear visual representation of the process. So whether it's a complex algorithm that needs to be understood, a business process that needs to be optimized, or a lesson plan that needs to be developed, flowcharts can provide the visual clarity needed to make sense of it all. Now that we've introduced the concept of flowcharts, let's delve into the symbols used in them. Flowcharts consist of various symbols, each having a unique purpose. So what do these symbols signify? Let's dive right in and start deciphering these symbolic elements. First up, we have the terminal symbol. This shape is typically an oval or a rounded rectangle. The terminal symbol is the bookend of your flowchart. It represents the start or the end of a process. Think of it as the once upon a time or the end in your flowchart story. It's your cue to know when a particular process has begun or when it has concluded. Now let's move on to the next symbol, the process symbol. This is typically depicted as a rectangle. It signifies a task or operation within the process. If your flowchart was a recipe, the process symbol would be the individual steps, like whisk the eggs or bake for 20 minutes. In the context of programming, it could represent a specific operation like initialize variable or calculate average. The process symbol is where the actual work gets done in a flowchart. It's where the magic happens. Imagine you're reading a book. The terminal symbol is like the first and last page of the book, indicating where the story starts and ends. Meanwhile, the process symbols are the various chapters in between, each describing a different part of the story. Together, these symbols help to create a clear and cohesive narrative in a flowchart. Keep in mind, though, that the terminal and process symbols are just two pieces of the flowchart puzzle. There are other symbols, each with their unique role, working together to create a comprehensive visual representation of a process or algorithm. That's just the start. There are more symbols to explore, so stay tuned. Let's continue our journey through the symbols used in flowcharts. Moving on, let's turn our attention to the input-output symbol. This symbol is a parallel-sided rectangle, like a squashed square if you will. It signifies the process of inputting or outputting data. In the realm of programming, this could range from reading from or writing to a file to displaying information on a screen. The input-output symbol is a crucial part of a flowchart as it indicates where data enters or leaves the system. It's like the gatekeeper of data in the world of flowcharts. Now, imagine a scenario where you need to make a choice. A left turn or a right turn, to have tea or coffee, to code in Python or Java. These are decision points, and in flowcharts we represent them with the decision symbol. The decision symbol is a diamond shape standing out from the rest. It's at these decision points that the magic of conditional operations happens. This diamond shape is where a condition is evaluated, and based on the result, the flow of the process can take different paths. It's like a crossroads in our journey, the outcome of which directs which path to follow. If the condition is met, you might follow the path to the right. If not, you might find yourself heading left. It's all about choice and condition. In programming, these decision points are where if-else statements come into play. If a certain condition is true, one set of actions is performed. If it's false, another set of actions is executed. The decision symbol encapsulates this beautifully, providing a clear visual guide to the potential twists and turns in the process. So there you have it. The input-output symbol, the gatekeeper of data, and the decision symbol, the crossroads of conditions. As you can see, each symbol in a flowchart plays a pivotal role, representing different aspects of the process or algorithm. Now that you know about the decision symbol, it's time to understand how we move from one step to another. The last symbol we're going to discuss today is the flow arrow. This symbol may seem simple, but don't let its simplicity fool you. The flow arrow is arguably the most critical element of a flowchart, acting as the director of the entire process. The flow arrow is the symbol that signifies the progression of steps in a process. It's the line that connects the dots, or rather the symbols. It's the guide that tells you where to go next after completing a particular task. It's like the thread that weaves the entire tapestry of a flowchart together. Imagine a flowchart without flow arrows. It would be like a city without road signs, a novel without words, a symphony without notes. The tasks, decisions, inputs, outputs, and terminals would all be there. But without the flow arrows, there would be no clear path to follow. Flow arrows aren't just about direction, they also illustrate sequence. They show us the order in which the steps in a process should be executed. They depict whether the steps follow a linear progression, or if there are decision points where the process may branch off into different paths. In a computer programming context, the flow arrow is akin to the flow of control in a program. It's the logic that determines how the program jumps from one block of code to another, based on conditions, loops, and function calls. So while the flow arrow might be just a line or an arrow on paper or screen, it's the lifeblood of a flowchart. It's the symbol that brings structure to the chaos, order to the randomness, and logic to the complexity. It makes a flowchart not just a collection of symbols, but a coherent, logical, and understandable representation of a process. In essence, the flow arrow embodies the very concept of flow in a flowchart. It's the symbol that enables a flowchart to live up to its name. With that, we've covered all the basic symbols in a flowchart, but how do they all come together? Let's find out. Let's now see an example of a flowchart for a basic algorithm. Picture this, an algorithm that evaluates whether a number is positive or negative. Simple, right? But let's break it down using a flowchart. The process kicks off with the start symbol, our terminal. It's like the opening curtain of a play, signaling the beginning of our algorithm's journey. Next, we move to an input symbol, where the user is prompted to input a number. This symbol represents any operation where we're either receiving or outputting information. From here, the flow swoops down to a diamond-shaped decision symbol. This is where the magic happens. The algorithm asks a question: is the number positive? It's a decision point, a fork in the road. The flow can now take two different paths, depending on the answer. If the number is not positive, meaning it's negative or zero, the flow moves to an output symbol, displaying the word negative. It's like our algorithm is gently breaking the news to us. But if the number is positive, the flow charts a different course, heading to an output symbol that displays positive. In either case, the journey concludes at the end symbol, the terminal that signals the closing act of our algorithm's performance. And there you have it, a simple algorithm represented visually through a flowchart. But don't let the simplicity of this example fool you. Flowcharts can be used to illustrate far more complex processes, from intricate programming algorithms to detailed business process modeling. They're a staple in system design, helping to map out the architecture of a program or a network. And they're a powerful tool in education, making abstract concepts tangible and easier to grasp. And that's it. You now have a better understanding of flowcharts and their symbols. Remember, flowcharts are a powerful tool for visualizing complex processes, so don't hesitate to use them in your own projects.